Hello guys, today we are discussing a question of Leetcode, that is find the pivot index. The difficulty level for this question is easy. Now what this question states that we have been given an integer array nums. Now we have to find pivot index. Now what is pivot index? Pivot index means any index whose left side, sum of all the elements from the left side is equal to sum of all elements from the right side. So it is strictly sum of all left elements and strictly sum of all right elements should be equal. That means, for example, let's say I have an array 1 7 3 3 6 and 5. So if we take this as the pivot index, so sum of all these elements is equal to 11, and if you see sum of these two elements is also 11. So this index is called the pivot index. So we have to find pivot index in the array. Now if in case we have many pivot index, we would always return the leftmost pivot index. That's the first pivot index that we find from the 0th index. So that's one thing. And in case we don't have any pivot index existing in an array, then definitely we would return a -1. So -1 directly states that we don't have any such index which results the right and left equal. So this is kind of a balancing index. So this question is strictly following the example from the running sum array or the prefix sum. So if you don't know the concept about how to find the running sum or the prefix sum, click on the eye icon on the top right corner of the video and you can find my video on a question that was meant to find the prefix sum or the running sum of a 1D array. Now let's also look at the constraints of the problem. So the constraints that are given to you are stating that your nums length, your array length can range from 1 to 10 to the power 4. So that's the length of the array that can be. And any number in that array would range from -1000 to +1000. Now let's start by understanding few examples and then come up with a brute force approach and then try to improve that approach gradually to reach to a time complexity of big O n. Now let's also understand few more examples to understand the edge cases. Edge cases, by edge cases I mean the case where we have to return -1 and the leftmost pivot index part. So let's try to understand few more examples to figure out what are the different cases that can be possible. Let's say I have let's say example 2 and this was example 1. So over here my answer was 3 because 3 is the index. So my indexes were 0 1 2 3 4 and 5. So 3 was my index, that was the pivot index. That's why my answer is 3. Now let's take another example. So in this example, let's say I have element as 2 -1 and 1. Now let's start finding sum of all the right and left elements of each and every index. So now let's take index I is equal to 0. For index I is equal to 0, I don't have anything on the left side. So left sum would be 0 because we don't have anything there, right? So that's strictly 0. And on the right side is 1 -1 plus 1, that's again 0. So that means 0 is my pivot index. So this is my 1 pivot index. But let's see if we have another pivot index or not. Let's go to I is equal to 1. So for I is equal to 1, that means this index. Now for this index, the left sum is 2 and right sum is 1. So this is not pivot index. If I is equal to 2, so I is equal to 2 means this index. I mean this index and not this one. Okay, so over here the left sum would be 1 and right sum is 0. So this is another example where your answer would be 0. Let's take another example where we again take another pivot index as example 3. Let's say I have an array 1, 2 and 3 and your indexes are 0, 1, 2. Now let's take I is equal to 0. For I is equal to 0, that means this index. So for this index, left is always 0 and right is 5. For I is equal to 1, that means your this index 2. So for 2, your left sum is 1 and for your right is 3. If I is equal to 2, that means your left is 3 but your right is 0. That means I don't have any pivot index. That means my answer is supposed to be -1. Okay, so this is few examples that you have for pivot index. So you see there is a case where you don't have any pivot index at all, so you return a -1. There is a case where your leftmost element was the pivot index because the sum of all the elements to the right of that 0th index element was equal to 0. So that's one case. Then you have an index that is not 0 or the last rightmost element, but it's somewhere in the middle. Now let's take another example. Let's say example 4 where I have elements as 1, -1 and 2. Now over here my indexes I'll mention 0, 1 and 2. Let's start by index I is equal to 0. For I is equal to 0, that means this element, my left sum is 0 and right sum is 1. For index I is equal to 1, that means this index right now. So for this left sum is 1 and my right sum is 2. For index I is equal to 2, that means this index. For I is equal to 2, my left sum is 0 and right sum definitely is 0 because I don't have anything to the right of this index. So that means my pivot index is 2. So this is my answer. So these are few edge cases, plus you may say these are different examples. And now let's see what is a brute force approach. First, let's go with a brute force approach and then try to resolve that approach to come up with a solution. So my target would be to reach up to a time complexity of big O n. And the brute force approach that we'll be discussing is time complexity of big O n square. So we would try to reach from n square to big O n. So this is our target. Okay. Now let's start by understanding the brute force approach for this problem. So now let's understand the brute force approach first. So the brute force, let's say brute force approach. Now why I wanted to discuss brute force approach first, because this will help you understand how you can transition from the brute force or approach that takes more harder complexity to reducing your time complexity. Now let's say the first approach that always comes to my mind is always to start with a particular index. Let's say I start with index 1 and I calculate the sum to the left side and then sum to the right side of the right index of this particular index. So if I start with for I ranging from 0 to n minus 1, so both of these inclusive. So I would start from 0 to n minus 1. Okay. So for if I equal to 0, then I don't have to find the left index, only right index. So is not equal to 0, then I'll find left sum. So for finding left sum, what we have to do? we have to run a loop for j is equal to 0 till I minus 1. So we don't include, let's say we are on this index, so we don't have to include this index in my sum, right? We only have to include from 0 to 7. We don't include 3. So when we are on the whichever index, we would range from 0 to that particular index minus 1. We'll add up till there. So I find over here, I find through this loop, I find left sum. Then if I is not equal to n minus 1. Why n minus 1? Because now I'm trying to find the right sum. So if my index is the rightmost element of my array, I don't have to find the right sum, right? So if I is not equal to n minus 1, that means it's not the rightmost element. Then I'll go for j is equal to I plus 1. Now why I plus 1? Because if we are on this index and we're trying to find the right sum, we would start from 4. So that means I plus 1. So we would start from I plus 1 up till n minus 1. So this is my j, and this will help me to find right sum. So I have found the right and left sum, and after all, so in case we are not entering this loop, my right sum would be 0. If we are not entering this condition, my left sum would be 0. That is definite. So over here we'll initialize left sum is equal to 0 and right sum is equal to 0 for each index. Practically for each index you would be start fresh, right? So this is 0. Now if my left sum is equal to right sum, I would return I. Now what is the time complexity of this code? Now for time complexity, let's try and calculate this. So this for index, this for loop would result in n iterations, right? And if we go to either left or right, let's say I am on the leftmost index, let's say 0th index, so this loop will not run, but this loop will run for the complete array length, right? This loop will run for complete array length. That means this itself can go to maximum n iterations, right? So it's n minus 1 practically, but let's, for a large number, let's take it as n only, or let's take it n minus 1 for now. But if we are on the rightmost index, then my this loop will run for n minus 1 iterations. That means for each index, in the worst case scenario, I have n into n minus 1 iterations. This is the worst case. That means n square minus n. Now we know for time complexity, we would ignore the lower order terms. That means we would ignore n. So that means my time complexity becomes n square. So my time complexity becomes n square. Now this is an approach that comes to my mind. This is the brute force approach, and this is the time complexity. And space complexity for sure is 1, because you haven't created any new array, right? So space complexity remains constant. For space complexity you have big O of 1. So you didn't have to create any extra space. So space complexity is 1. So this is the brute force approach. Now what can we do better to come up with an big O n solution? Now if you see, I am always calculating the left or the right sum again and again, but for each index this would be different, right? So if I calculate a running sum and then try to figure out some solution, okay, now let's try to understand if that is feasible or not. Let's say let me take this example again. 1 7 sorry 7 3 6 6 5. Now I don't care about this element because it can be 3 4 anything, because I know for sure this is my pivot index. So that's why I'm again and again changing it. So don't mind that part, please. So for index 1, let's say I start with index 1. Okay, for now I is equal to 1. What is my left sum? Left sum would be a of 0, and right sum would be a of 2 plus a of 3 plus a of 4. How many indexes I have? 1 2 3 4 5 till 5. I have a5. Sorry. So I have till a5. So these indexes. Now I go to I is equal to 2. For I is equal to 2, I have a0 plus a1. And right sum would be, let's keep it little aligned so that it helps you to understand the logic. A3, A4 and A5. Let's go to index I is equal to 3. I'm not calculating the sum right now. I'm trying to figure out an approach to reduce my time complexity. So I'm not writing the answers for these right now. So this is A0, A1, A2. And for here, write sum A4 plus A5. This is my right sum. Okay. Now let's go to index 4. A0, A1, A2 plus A3. And for right sum, I would only have A5. Now, if you see, there is a pattern. So every time you come up with new index, there is another element added to the previous index's sum. So if somehow, if I had this memorized somewhere for the index 1, I have this memorized somewhere. So when I come to index 2, I just have to add the last element, last value. So if I'm on index 2, so this is practically index 2 minus 1, right? This can be represented as a 2 minus 1, right? Now if I go to index I is equal to 3, so if I have stored the index ith left sum somewhere, let's say this is stored somewhere, and I just add a of 3 minus 1 somehow. So if this is already calculated, I don't have to traverse the complete array. I don't have to traverse from the 0th index to that particular index. I always have that particular value, and I just have to add 1 minus. So the current index minus 1. So if I go to 4th, if I have this somewhere stored, this was for index 3, the left sum of index 3, I just add another element. Now let's go to right side. What is on the right side? On the right side, if you see, if I memorize this somewhere, for I is equal to 2, I just have to remove the particular index. So for I is equal to 2, from this sum, if I remove I is equal to index 2 value. So I'm on index 2, I just have to remove index 2. If I memorize this, then I have to remove just the index 3 from this sum. So this is how this will go on, right? So if somehow I try to memorize the left and right of the previous index, I can reduce my loop that was these loops. I can reduce these loops, right? So reducing these loops would reduce this to complexity of 1 only. Then my time complexity would come up to only n. So this is my target now. How can I do it? So that's another question, that how to achieve this particular part, how to store or memorize these two values from the previous values. Now, we have a very good approach for this. We have a prefix sum or the running sum approach for this. Now, what is that approach? Now, let's say for this array, let me find the prefix sum. Now, if you don't know what is prefix sum or the running sum, I would highly recommend you to go and watch the video that I have linked on the eye icon on the top, and then come up with this question, because this will help you understand the approach. I would I would try to help you in case you have not watched to some extent, but I would highly recommend you to watch that video first. Sorry. So now let's calculate the prefix sum. Now, what is prefix sum? Prefix sum is nothing but sum of all elements from 0 index till the particular index. So that means if I'm on 7, that means sum of all elements from 0 till 7. If I'm on 3, so that is sum of all elements from 1 to 3. So now let's try and find a prefix sum. So prefix sum array for this particular array is 1, 8, then 11. 11 plus 6 is 17. Then you have 17 plus 6 is 23. And then 23 plus 5 is 28. So this is the prefix sum. Now, when I am on, let's say when I am on a particular index, let's say I am on particular index that is 8. So I can find the sum of all elements on the right side without calculating, because I have this number directly. Let's say I am on index this one, that is 6 from my original array. So that means sum of all elements from here till this place. So practically I have to just take this number into account. So this is my left sum. Now, how do I find the right sum? Now, right sum is nothing but the value of your rightmost element minus your current index. Now, let's take this with an example. Let's say I go on I is equal to 1. I start with I is equal to 1. Let's ignore the I is equal to 0 case for now. Let's ignore that case totally for now. So on I is equal to 1, that means 8. My left sum is 1, which is true. If you go and see in this array, left sum is 1 for this index. Correct? Now, when I go to right, now for right sum, what I want to know is sum of all elements from 3 to 5. That means if I add the complete array and minus the sum till this value. True? So that means my last index, last ith index, that means n minus 1 of my prefix sum, that is 28 minus my 8. So what is that value? 8, that is 20. Now if you calculate the sum for this particular value, that is 3 plus 6 plus 6 plus 5. What is that? 20. Now let's go to I is equal to 2. For I is equal to 2 means I am on this index. I am on 3. For 3, that means for prefix sum, I am on this part. So my left sum is straightforward. Index minus 1 is my left sum. That is 8. That is pretty straightforward. Now for the right sum, what I have to do is again 28 minus the current value in the prefix sum, that is 11. How much is that? That is 17. Now if you see if that is true or not, 6 plus 6 is 12, 12 plus 5 is 17. Now I go to I is equal to 3. Now if you see, I have not iterated the complete array for finding these values. I have these values already calculated. I just have to do addition or the subtraction operation, which is practically time complexity of big O1. So we don't have any time complexity for those operations for now. Now I am on index 3, that is 1, 2 and 3. I am on this index. Now let me remove this. Let me remove this for better clarity. Okay. 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 So I'm on index 3 for this sum. So for that, my left sum is directly calculated, that is 11. For left sum, I have to do nothing. But for right sum, I would say 28 minus 17. That is again 11. Now I find left and right are equal. I would break out of the loop, because if you remember in the question, they were asking us to find the leftmost pivot element. That means the first pivot element that we find in the array. So this is my pivot element. We practically don't have to traverse to the end if we find the first value. Correct. But let's say let's for understanding purpose, let's go to another index and also try to understand this logic better. So if I go to index 4, so let me remove this everything. Okay, I am on index 4, that means index this one, and in my nums actual array I am on index 6. So for this, my left sum is definitely 11. I didn't have to calculate that, that is pre-calculated. And right sum is 28 minus 23, that is 5. Practically for this 6, right sum is 5, and left sum is 17. So these are two not equal value. If I is equal to 5, let's say I is equal to 5, that means I am on index this one. So let me go to index this rightmost index. Now for rightmost index, what is the left sum? Left sum is definitely 23, and right sum would be 28, that is the last value, minus the value itself, the index in the prefix sum array. So that is again 28, that is 0. So you don't have to do anything, right? So this is how you find this. Now let's try to write an algorithm for this and then understand this algorithm with a code. If you're liking the explanation till now, please do not forget to subscribe to our YouTube channel and like the video, because this will give us a motivation to create new videos on any other questions that you guys want us to, or any questions that we can plan of. So please do not forget to subscribe or like to this video. Now let's understand the algorithm. So algorithm is pretty simple, where we have the time complexity of big O of n, and your space complexity may vary from big O of 1 to or big O of n. Now this depends on the running sum array. Now this running sum array, if you go and check out our video that is on linked in the eye icon on the top, you will understand why the space complexity may be either big O of 1 or big O of n. Now let's move to the step 1. Now in the step 1, we would find the prefix sum. So prefix sum, if you remember from our explanation, that is the sum of all elements from 0th index till that particular index, and we'll find this for each and every index in that particular array. So first point is finding the prefix sum. Now after you have the prefix sum, you would first check for index 0 if index 0 is my pivot index or not. If index 0 is pivot index, that means you will not have to enter the loop. So for index 0, how do we check? Because for index 0, definitely the left sum is always 0, so we just have to find the right sum. So for right sum, we know, so prefix sum of n minus 1 means the last element of the prefix sum, that is the sum of the complete array minus the first element of the array, the 0th element of the array. So if that is equal to 0, that means my pivot index, the first pivot index for my array is 0. So I'll straight away return 0. I don't have to go ahead and check for any other indexes apart from 0. Now, if this is also done and we don't find this step correct, means returning any index, then we'll go to step 3. Now, step 3 states that we would start iterating from index 1 to the last index. Last index is n minus 1, which we already know, because the n is the size and n minus 1 is the last index. So we would start from 1 and go up to n minus 1 and try to find the left sum and the right sum. Now the formula for finding the left sum is just prefix sum arrays I minus 1th index. So if we find the I minus 1th index, that is my left sum. The right sum would be prefix sum of n minus 1. That's the last value in the prefix sum minus the current value of the prefix sum. Now this is PF. Okay. So the current value of the prefix sum. If we find the difference of these two, that means we have this as the right sum. If these two are equal, then I is my answer. And we would straight away return. We would not go ahead and traverse till the end of the array, because we don't care, because our question states that we want the leftmost pivot element. That's the first pivot element. Even, let's say, even after iterating the complete array, we haven't returned anything. That means we come out of the loop either ways. That means we have not returned anything. That means we didn't find any element as the pivot element. That means now we will return -1 in that case. So this is the algorithm for this question. And now let's try and understand the time complexity of this question. So time complexity is, for this step, the time complexity of big O of n, and for step 3, my time complexity is of big O of n again. So total time complexity becomes n plus n, that is 2n. So this is my time complexity. Now we avoid the constants in the time complexity equations. That means my time complexity is big O of n. That is why I wrote big O of n in the starting. Okay. Now space complexity would vary from 1 to n. That depends on your calculation of your prefix sum or the running sum array. Now that depends on the interviewer what you have to choose for space complexity. And to check that example, you go ahead and click on the I icon on the top. Now let's go ahead and see the code for this example, and let's try to map each and every step there. Now the code that I have written is in Golang. You can write the code in any language of your choice, whether it is C++, Java, .NET, Python, JavaScript, any language. If you understand the concept, you understand the algorithm, you just have to replace the syntaxes from this code and you're good to go. So this is written in Go, and I don't think we have included any specific Go syntaxes over here. They are pretty simple syntaxes that are available in all the languages that you have in right now. So over here, if you see, I have a pivot variable created which is initialized to -1, correct, and I have an n, that is the length of the nums array. This step, this particular loop is my step 1. This is step 1 to find the prefix sum. This is finding the prefix sum. Now for this example, I have taken space complexity as big O of 1. So that is why I have taken the complete, I have actually modified the nums array. I have not created another array, but you can go ahead and create another array to calculate the prefix sum. That's up to you and up to the interviewer. Now for step 2, that was checking if index 0 is my pivot index or not. So over here, this is step 2. I'm checking if the leftmost index, that is index 0, is my pivot index or not. So this is my prefix sum now after this step. So from prefix sum, I am taking the last value minus the first value. If it is equal to 0, that means I'll return 0. So 0 would be my prefix sum. Now, even if this is not correct, I would go to step 3. So this is my step 3. So in step 3, what I have done is I have started to iterate from index 1 to n minus 1. Now, why this is n minus 1? Because my I is less than n. That means I would go up to n minus 1, and when I becomes n, I would break out of the loop. So this is my left sum. So if you see, left is nothing but prefix sum of I minus 1. Then my right sum is prefix sum of last value minus the prefix sum of current value. If you try to map this with this example, so prefix sum of I minus 1, prefix sum of n minus 1 minus prefix sum of I. So this is my right sum. So if left and right are equal, I would say pivot is equal to ith value. Now over here, I could have directly written I, and I didn't have to do break, but for better understanding, I just wrote pivot equal to 1, and I break out of this for loop. Okay, and in the end I return pivot. Now if I don't enter this condition anytime, that means I will not modify the pivot which was originally minus 1. If you see, originally it was minus 1, that means it would return minus 1 if I don't have any pivot index. That is why I have written directly pivot. But if you return minus 1, return index from here, then you can directly return from here minus 1, and you don't have to create the pivot variable. So you can reduce creating the pivot variable. So this can be avoided. But for better understandability or readability, I created a pivot index which will not harm my space complexity, because that's a very small variable, an integer variable. Now, hope you understand the explanation for this code, and if you want to find this code, I have my GitHub repository whose link I would list down there, down in the description, and there I have different folders for according to difficulty level of the Leetcode. So easy, medium and hard. So you can directly go ahead there and you can search for this particular folder. For inside the easy, you will find a pivot index folder there, and you can directly go ahead and refer to this code in case you want this code to be visually present and you want to do something there. Okay, so hope you understand the explanation and it was helpful for you guys. So that's it for this video today, and in case you liked the video and it was helpful for you, please do not forget to like, share and subscribe to our YouTube channel. Also comment down below in case you want any particular question from Leetcode or Geeks for Geeks to be solved by us on Golang, or any other topics that you want us to cover for you guys using Golang. So go ahead and comment down below as much as you want, any topic on Golang, using Golang. We appreciate you guys to do that.